maximum and minimum values of trigonometric expression. A sine x plus b cos x can be rewritten using an expression of the form r sine x plus minus alpha or r cos x plus minus alpha, where alpha is the phase angle and r is the amplitude and depends on the values of a and b. Now we go to refer sine wave. This is the sine wave. Okay, what we can observe from this graph is that sine x, okay, sine x, the maximum value for the sine x, y equals sine x, or sine wave is 1. So you can see that the above one, the biggest value it can go is 1. Okay, where this happen when angle is 90 degree or pi over 2. Okay, and the least value it can go is for sine x or sine wave is minus 1. Okay, the first one we can have here is 3 pi over 2. We will have this graph. Okay, its minimum is here minus 1. Okay, this happened on 270 degree. Okay, now let's go and refer the cosine wave. The cosine wave we have like this. Okay, the maximum value for the cos x is 1 also, so it's happened here, here, and so on, because this wave will be repeating indefinitely. Okay, and the least value is minus 1, so this is where it will happen at pi. Okay, cos pi is minus 1, cos 2 pi is 1, cos 0 is 1, and then cos pi is minus 1. Okay, cos pi over 2 or cos 90 is 0. Cos 3 pi over 2 is 0. Okay, cos 2 pi is 1. Okay, now we can have a cosine and also sine wave. So maximum value for sine 90 is 1. Okay, sine 90 here is 1. Cos 0 is 1. This is cos 0 is 1. This is the maximum value. And cos 2 pi, okay, is also 1 just now. Okay, so cos 2 pi is 1. And then for the minimum value, we have here sine 3 pi over 2. Okay, so 3 pi over 2 here we have minus 1. It's supposed to be minus 1 here. Okay, and cos pi is minus 1. Okay, because cos pi is minus 1, which is brings us the value for the minimum. Example 1. Find the maximum and minimum values for the expression 3 sine x minus 4 cos x, and find the values of x where x is from 0 until 360, for which the expression has the extreme values. Okay, what does it mean by extreme values? Okay, extreme values here referring to the maximum and minimum value for this function. Okay, what we can see here, 3 sine x minus 4 cos x consists of two different trig functions. So we will have to go to simplify these two trig functions to become only one single trig function. So that is easy for us to find the value, the maximum, and also minimum. Okay. Alright, solution. Let 3 sine 3x minus 4 cos x. Okay, we have to use our sine since here this is sine x. So sine x minus alpha. Then next is to go to expand this, okay, using the compound angle. So you have r sine x cos alpha minus r cos x sine alpha. Okay, now we go to compare both sides. So equating coefficient of sine x and cos x, we will have here, okay, this is a sine x we have, and there's a sine x. So the coefficient for the left hand side one is 3, and the coefficient of the sine x on the right hand side is r cos alpha. And so we will do for the cos x. Seems that we have the coefficient of this cos x on the left hand side is 4, and the coefficient of the cos x on the right hand side is r sine alpha. Now you can see we will have equation number 1 and also equation number 2. As usual, we'll go to find the value for the r and also alpha. Then after that you will have one single function. Okay, so we will do our equation number 1 square, and then equation number 2 square equals to r square equals 9 plus 16 equals 25. So that we have r as 5. Just select the positive value. The next step is in order to find the acute angle. So we have to divide equation number 2 divided by equation number 1. We have tangent alpha. Then we have 4 over 3. And then tangent is up, tangent 4 over 3. Then 53.13 is the acute angle. Okay, now these two different trig functions is already become one single function. This is 5 sine x minus 53.13. And now we will go to find the maximum value for 3 sine x minus 4 cos x. It is also same as we are searching for the maximum value for this one single function. So we will have 5 because it occurs when sine x minus 53, this part is 1, because the maximum value for sine wave is 1. So if it is 1 here, so 5 times 1 will be 5. That's why we have the maximum value for this 2 sine x minus 4 cos x is 5. Okay, it has happened when sine 90 at sine 90 degree. Okay, this function sine 90 is 1. And then we will have here x minus 53.13. Okay, equals 90. And then we have the value for x equals to 143.13. This is the maximum value. Okay, happen at x equals 143.13 degree. And because here theta, it is given as from 0 until 360, so we only have 1. Okay, we only have 190 degree. Okay, the minimum value for 3 sine x minus 4 cos x, okay, equals minus 5. It occurs when sine x minus 53.13, okay, which is equivalent to this function just now, okay, equals minus 1, because sine wave, the minimum is minus 1. And it has happened on 270 angle, okay, or sine 270, we will have the value is minus 1. So that we will have here sine 53.13 equals 270. Okay, so we have x equals to 323.13. This is because theta is from 0 until 360. Find the maximum and minimum value for the following function. Now we have a function f theta as 1 over 3 plus sine theta minus 2 cos theta. This is a little bit different because it is a reciprocal function. But what we want to concern here is this sine theta minus 2 cos theta, which consists of two different trigo function. Okay, now we will go straight away to the sine theta minus 2 cos theta to simplify the function first. Okay, solution, we start by expressing the denominator of this f theta as in the form of 3 plus, okay, sine theta minus 2 cos theta will become r sine theta minus alpha. Okay, so now we go to sine theta minus 2 cos theta, okay, which is equivalent to r sine theta minus alpha. And then we will go to expand this using the compound angle with r sine theta cos alpha minus cos theta sine alpha. Okay, so we split this so that it's easy for us to compare now. The coefficient of sine theta and also cos theta for both sides. So equating the corresponding coefficient gives r cos alpha equals 1. Okay, this is r cos alpha equals 1 here. Okay, equation number 1. And the coefficient of cos theta here is 2. Okay, equals r sine alpha. Okay, this will give us equation number 2. The next step is to go to square equation number 1 and also equation number 2, and we just add up together. We will have r square cos square alpha plus r square sine square alpha equals 1 square plus 2 square. And the next one we have to go to factorize this r square, and then inside here, okay, we have this cos square alpha plus sine square alpha, which is 1. So therefore r is square root of 5. Okay, and the second part we will go to divide. Question number 2 divided by question number 1, we have r sine alpha over r cos alpha equals 2 over 1 when we have tangent. So therefore we'll have tangent alpha equals 2, and alpha is 63.4. And then we put it back into the question just now, the equation. This is r sine theta minus alpha as 35. For this, r sine theta minus 63.4. And what we can observe now, the original question, okay, has already become 1 over 3, and the sine theta minus 2 cos theta is already turned into 5 sine theta minus 63.4. Okay, so this graph, okay, attains a minimum when sine, okay, sine theta minus 63.4 is a maximum. Okay, because the bigger we have in the denominator, it will be a smaller value. So it attains a minimum value when sine, okay, this sine theta is maximum. All right, and now we have sine theta minus 63.4 has maximum value of 1. Okay, remember that sine wave maximum is 1, which occurs when, okay, this is sine 90. So we have theta minus 63.4 equals 90. And then we will have the value for the theta. So we have theta now. We will have 153.4 degree. And this function will have a minimum turning point on the graph. F theta is at 153.4. Then we just input into this function. Then we have the value for the y, or this f theta, or we just go to 1 over 3 times 3 times 5 times 1. So we have like this will be the value for the minimum turning point, or where this function has a minimum point. Similarly, the graph of f attains a maximum value when sine theta minus 63.44 is minimum. To get maximum, the sine must be minimum. Okay? And then now, sine theta minus 63.4 has a minimum value of minus 1, which occurs when theta minus 63.4 equals 270, or sine 270, the value is minus 1. So therefore, okay, this is what I said just now, sine 270 equals minus 1. And then theta is 333.4. A maximum turning point on the graph, okay, on the graph of f theta is 333.4, and then 1 over 3 minus 5 times 1 is 3 minus 5. Okay, this is what it happened just now. When sine 270, this sine wave is minus 1. You can see this is minus 1.